Okay, so hopefully I can hold your attention before lunch. I'm going to talk to you a bit about some primitive sharks called bullhead sharks. And bullhead sharks are very primitive, as you can see by their two of their dorsal fin spines. They also have a very curious durophagous condition. And although the evolution of sharks is very poorly known because they have a cartilaginous skeleton and there's a preservational bias towards teeth, they are known to be basal to neosalaceae, which are modern sharks, rays, and skates. So 3 genera define heterodontids. Paracestration and Proheterodontis disappear from the fossil record before the Cretaceous, while Heterodontis continued to diversify throughout the Cretaceous, and they also occupy our oceans today. So for my independent study, I researched the intrarelationships between heterodontiforms, and this was using parsimonious approaches with 112 morphological characters. Unfortunately, only 28 were informative. However, this is fairly substantial, being that the preservation potential is so low. But also, during this cladogram investigation, I identified 2 new species that were previously unknown. So ultimately, though, the interesting part of this cladogram shows that there were differences in the Ecomorpha type between heterodontis and paracestration. So the Ecomorpha type of durotrophic littoral is defined as having a large head, a blunt rostrum, a rostrally placed pelvic girdle, pelvic fins, and a caudal-placed pectoral fins and first dorsal fin. Together, combined, these allow sharks that are durophagous to perform a punting locomotion off of the substrate. Also, this Ecomorpha type is defined by a low heterocircle tail angle. All of these you can see in the above image of paracestration. However, the almost exact opposite has been selected for in the extant Heterodontis. So during the late Jurassic, it was defined by an oceanic regression and a global oceanic cooling event, which contributed to a decrease in the amount of invertebrates occupying these areas. And so it is supposed that these sharks are relatively unstable as it is. However, paracestration would have been much more unstable in deeper waters to attain food. So the extant Heterodontis is presumed to have a much more stable Ecomorpha type to migrate into deeper waters, which they have been observed to do during the winter times in our current oceans. So I also performed a molecular phylogeny to look at the interrelationships between extant heterodontids, and this was done using maximum likelihood using mitochondrial NADH2 sequences. And so heterodontids do prefer warm, coastal, and shallow waters, and this molecular phylogeny shows that there was a northward migration that occurred from the south of America. And during the mid-Eocene, there was an oceanic warming event and a reduction in the disparity of temperatures from the equator to the pole. So this, the timing of their divergence compares to these mid-Eocene events that allowed their northward migration up the coast along North America. And then following that, they then further migrated to the Asiatic coast and the Australian coast. So in conclusion, the Ecomorpha type of Heterodontis made the genus more successful in food acquisition during the late Jurassic, and their current distribution was influenced by a global oceanic warming events and a reduction in the disparity of temperatures from the equator to pole. But ultimately, this highlights the vulnerability of bullhead sharks in occupying the coral reefs and their pelagic environments and the habitat that they occupy. So, thank you.